Well, today I'm with my friend Todd Smith. He's the CEO and co-founder of Taho, and Taho is the world's first federated infrastructure performance software. It runs workloads faster, costs less than legacy orchestration, and works with your existing stack. So, Todd, great to have you today.
Thanks, Walter. Really happy to be here.
Awesome. Well, let's get into the problem. I heard you say some things about the past 10 years of computing versus the future 10 years and what's expected in the future. Let's talk about the problems with where we're at today as far as computing goes.
Yeah, so it's actually pretty simple. All of the computing infrastructure that's out there today, across the cloud or even any bare metal or hybrid environments that people have, they were really built on the foundation of application needs and SaaS needs of yesterday. And fast forward to today with the introduction of AI, where workloads are about 100 times what they once were, we've really got we're putting a lot of pressure on that existing computing infrastructure. It's really, it's the topic of the day in tech, which is, hey, there's not enough hardware. The hardware's not fast enough. There's not enough data centers, and there's not even enough energy for the future data center needs, especially since the advent of AI. And that's the problem. There's basically we have a major bottleneck on computing infrastructure and a lot of demand for more. And what we've identified, with this problem is we feel as though everybody's trying to throw more hardware at a problem that really just needs a better software solution. So that's what Tahoe's aiming to do, is solve the lack of compute hardware with a software solution to get far more out of the hardware infrastructure that's out there today.
So I've been talking to CEOs of AI companies, and they all have said, well, Kubernetes is not going anywhere, so we're definitely leveraging that. So it seems like your solution could be the next evolution of Kubernetes, or maybe an alternative or a complement. So can you describe that a bit?
Yeah, and it's actually all of the above. You definitely have to meet your customers where they're at, right?
Hmm.
And so we're not looking to uproot or remove, dethrone Kubernetes. You can't. Okay, it's just plain and simple, you can't. So we've built a middleware layer that plays really nice with Kubernetes. It can really help you from an efficiency perspective to help orchestrate your current environment far better than Kubernetes orchestration can, or even Slurm, or even OpenShift, anything else that you're using that's out there today. And in playing nice with Kubernetes, we also have opportunities to, number one, land in the environment, leverage our product for very specific workloads while not disrupting the balance of your Kubernetes environment, and then enable our customers the opportunity to migrate their workloads over at their own pace in those environments, and they gain efficiencies and performance every step at every turn. So again, we're not looking to dethrone or remove Kubernetes altogether. Interestingly, the more of our product that you use, whether it's in concert with Kubernetes, just existing on the same hardware as your current Kubernetes workflows are, or even in some cases, there may be optimizations where the team just opts to um, uh, really just remove that Kubernetes from specific workflows overall and just leverage our product. That's heavier weight, but it's possible, and there's many levels at which a customer can engage with our product and leverage it, and they're going to get big gains every step of the way.
Hmm. I saw in some places you mentioned at least two times more efficient, and that translates into lower costs and better satisfaction for customers and everything like that. So, and then I've also seen 30 times more efficient in some cases. So, can you explain some of those gains?
Yep, yep. So when we talk about doubling, we actually talk about our commitment to our customers. So we're going to double the productivity of their existing environment when they leverage our product. It's a guarantee. So if they're not getting at least double that performance, they're not paying anything. So that's where the doubling always comes from. That's what
Hmm.
we like to index to. There's a lot to be had in cutting the computing costs in half for many of our customers. So we do like to index to that. Now, we do have some great prototyping that's really fun to showcase to people. And We leverage different LLMs when we do that prototyping. So in a scenario where we're doing a text to image LLM and we run a text to image inference into that LLM, generating some sort of graphic. Oftentimes, when we leverage our product over the existing orchestrator, what we're seeing is roughly a 10x gain in that scenario. Then, in an image to text scenario where you might be doing some image analysis, we see that a lot of times in the medical field.
Hmm.
We're going to get about a 15x improvement. And then the prototyping where it's just a straight text to text, where we're just asking or prompting the LLM to provide us just a textual response, that's where we're seeing the 30x gains.
I've heard you talk about the control plane being a bottleneck, like a taxi dispatch service versus the current RideShare type scenario. Can you talk a little bit about that?
Sure, sure. So today, your typical orchestrator is set up so that it creates a queue, right? So workloads come into your data center and they enter a cluster or pod of containers that'll hold it in a queue. The orchestrator will hold it in a queue and then schedule it to be executed within specific nodes within your data center. So all those workloads stacked up in a queue and they're waiting for their turn to go in and be processed or computed in that and run in that specific piece of hardware. In our scenario, we're no longer doing that. We're removing the queue. And instead of the traditional queue that you're used to seeing, when we talk about our federated solution, what we're doing is we're leveraging all of the hardware as a single, as basically a team environment computing node. So when we talk about the taxis, we're talking about, hey, when you call for a taxi, the dispatcher puts you into a queue and you're going to get the next cab that's up for a fare. Whereas if you're using like a ride service, the ride services and the applications that are out there today actually leverage each one of the devices or each one of those mobile devices that's housed within that ride provider. They're all talking with one another and they're orchestrating between each other who's going to pick up which fare, who's closest, who's in the area, and that's all pre-orchestrated. So each one of those nodes is smart. Each one of those nodes negotiates who's going to get which fare with one another. That is exactly what we're doing in the computing stack, and we have all of your GPU and vCPU negotiating with one another, leveraging our product to negotiate with one another who's going to do what portion of every computing job. So that's why we draw the distinction or the similarities where we compare. Hey, in the old way of computing, there's a queue, everything has to wait its turn, and there is no prioritization schedule there based on any type of efficiencies. To a large degree, they're just waiting for the orchestrator to give the different pieces of hardware the work to be done.
Hmm.
Whereas in our scenario with the fabric, we create a single computing fabric with all of the computers available, with all of the GPU and vCPU available, and they negotiate it out themselves, much like the ride sharing applications do today.
Nice. I heard you say it was also a lot more simple because there aren't YAML files and different things like that and scripting. It's very simple. Can you talk about that a little bit?
Yeah, yeah. So our product negotiates all of the scheduling, orchestration of the workloads itself. So in our scenario, when a GPU or vCPU is busy, the workload is then just passed off to the next available portion of the computing stack, right? So whereas today, YAML files need to be adjusted for optimizing or for making certain that you're removing all the idle time that you can, our product naturally does that. So it naturally leverages the available compute that's available and closest to the work that needs to be executed. So you no longer really, the natural state of our product is optimizing the environment. So you no longer have to reorchestrate based on the different types of workloads that you have or the different types of workloads you want to get done. because we have them all connected together, orchestrated by Taho, and the fabric that we've created with Taho and all of your computing nodes, they'll just negotiate what needs to be done where at any given moment, rather than having to re-architect or manually restructure how all those workloads are going to be getting done.
I also heard you talk about the no need for cold starts anymore. So is that a big factor?
Basically, we set up a scenario where we've reduced the cold start times because everything is a cold start in our scenario, right? You no longer have to map all of that. You don't have to spend all of that time mapping your LLMs to your GPUs. Once they are mapped one time, they're just always available, and that information is always available to the computing nodes. So we love bragging about it. We love showcasing it to people, and certainly it's one of the more fun part of the jobs because it starts to live up to the promise and the vision of our product, which is we're building alien software
Nice.
to reinvent computer science to a degree. So
Who would be an ideal customer profile for you?
we love large brands that have a very high computing cost. So anybody that's in the 8 to 10 figures realm with their annual computing costs are businesses that we are really aiming to help. At the same time, we are able to help out teams with smaller computing environments. However, the bigger the environment, the more impact we can have. Um, the one thing that we look for in those computing environments are the companies that are seeking to they're seeking to overhaul their unit cost economics. We are aiming to help everybody out with unit cost economics of providing their compute or providing their products through computing.
Awesome. So how should people engage with you and learn more? What would you like them to do?
Yeah, I'd love them. Just go to our website. It's Taho, Taho.is. And you can think of it as infrastructure software. So Taho is infrastructure software, and they can find us at Taho.is, Taho.is, and there's plenty of ways to reach out to us and engage us from there, and also check out our product.
Is there an AI agent or an AI component inside the software that you're doing?
So there is a little bit of secret sauce in there. There is, and we're certainly looking to continue growing that into the future.
Nice.
So yeah.
All right. Well, talking about the future, anything exciting on the horizon that you can discuss?
Um, one thing that we're enabling with the product right now is really the opportunity for people to even map out automatically map out the environment that Tahoe is glued to. So the second you deploy the product, you're going to get real-time data on what that entire environment is executing and what nodes are performing what jobs. So that's some additional telemetry that just comes along with the product. It's not the core value of the product, but it's cool to see. It's cool to see the environment at work, and especially once you go to deploy the product.
Awesome. Well, Todd, this has been super exciting learning about Tahoe and your amazing solution. So looking forward to staying in touch, watching the company grow, and just seeing more adoption.
Likewise. Appreciate you having me on today, Walter, and for helping get the word out.